we're going to be working with radicals to see if we could come up with some values from these ideas. All right, so here comes this one. So it's asking us to evaluate the square root of 13 times the square root of 13. There are no ways we could do this is to have the root of 13 times itself, right? So we're gonna get the root of 169. And if you take the root of 169, the answer is 13. So that's one way of getting that answer out. Another way is to interpret the root of 13 in exponent, which is going to be a rational exponent. For example, the root of 13 is going to be the same thing as 13 raised to the half. And we're going to multiply that by 13 raised to the half. Remember, though, one of the rules of exponent is that when you multiply the same base, all right, as you can see, 13 times 13 here, we'll keep the base and we're going to add the exponent. So a half plus a half will give us 13 to the 1. So we're referring to this half power here plus this half power becomes 1. So 13 to the 1, and this is the identity exponent, which makes this 13. All right, so let's take a look at this question here. If I have the square root of 5 all over 4 square root of 125, there are a few ways I could go about this, right? So let's take a look at this. I could keep the root of 5 on top, but underneath, I'm going to actually split this up into 25 times 5. I'm able to do that because of the power that the radicals have. So 125 is the same as 25 times 5. So I'm able to use the power of the radicals there to actually split this. And then I'm going to take the square root of the 25. And mark you, I didn't just use any number. I focus on the largest square number that is a factor of 125. And that is 25. So in this case, if I should go further, I'll have the root of 5 all over 4 times, and we'll take the square root of the 25 there, we'll get 5, and then we're left with the root of 5. As you could see, the root of 5 could cancel itself one time. So on top, we'll have 1 over 4 times 5, which is 20. Another approach to that same question is that I could take a look at the root of 5 divided by the root of 125 in another way. For example, so I'll have this start. But I am able to take this 4, since it's a part of the denominator, it's underneath. I could let it be 1/4 from early. And then I could make one exponent I could make one radical, should say, from this, because you're able to do that with radicals as well. So at this time, I could cancel the 5 and the 125 there. So let me write the next step. So I'll have 1/4 outside. Then I'll have the square root of 5 into itself is 1, and 5 into 125 is 25. So at this moment, what I'm left with is 1/4. If I should take the square root of the 1, I'll still get 1 at the top, and the square root of the 25 will give me 5. And if you work this out, you'll get 1 over 20, just the same. So there are various ways to approach these problems, and whichever way you see fit works. All right, so for this one, as you could see, one of the easiest ways is to multiply your radicals, as you see we've been doing. So this is the third root here but I could multiply the radicand. So I'm going to multiply the 9 times the 6. So 9 sixes will give me about 54, right? So this is going to give me 54 here. So I multiply the radicands just to make it 1. So I have one radical dealing with. Then because I'm dealing with the cube, right? I could just find the largest cubic number that is a factor of 54. And if you don't know them, you could take a look at the quick list that I have here. So I'm seeing where 27 here could help me to work that out, because 27 times 2 will give me 54. So we could take it that way. So you could see here what I'm going to do is I'm going to rewrite this as the cubic root of 27 times the cubic root of 2. I am able to find the cube of the 27 here. So I'm able to get an integer there, and that's going to give me 3. And then I'm left with the cubic root of 2. So the final answer is 3 cubic root 2. And that's fine. In a similar approach, we're going to look at this question. So I'm going to multiply the radicands, which is 24 times 8. And 24 times 8 will give me about 108, right? All right, so 24 times 8 will give me 192. So 24 times 8 is going to give me 192. So basically, I'm trying to find the square root of 192, and I'm representing this in radical. So it's not like I need a decimal value. Now I'm going to try to see which square number or the biggest square number that is a factor of this. So I could just take a look if I don't remember. So I have a list of square numbers here. So we want to know which one of these numbers, right? So you could just divide through by any one of these. You could divide by the 4, divide by the 9, divide by the 16 until you get an integer, right? So 64 seemed to be the biggest one that really works right there. So I'm going to use 64 times 3. 64 times 3. So 64 times 3 is actually 192, right? So it's all about finding a perfect square that is a factor, but use the biggest one. If not, it's going to be incomplete. So what is the square root of 64? 8. Can we break down the root of 3 further? No. So this is the final answer right there. All right, let's take a look at this other one. So if I'm looking at the cube root of 375 divided by the cube root of 648, based on the power that we have with this radical, right? With the radicals, we are able to just divide both radicands to make one thing here, right? And then what I want to do is I could try to break it down. So I'm going to have to brainstorm. If I can't see, if these are not cubic numbers right now, right? And they are not, then I'm going to have to find some numbers to break them down. So if I divide both by 3, and I am coming up with this to break it down. So if I divide this by 3 and this by 3, I'm going to end up with the cubic root of 125 over 216, right? So I'll end up with that, which means that at this time now, I could take the cubic root of 125. Remember, 5 times 5 times 5 give you the 125, and 6 to the third is actually 216. So the final answer is 5 over 6. All right. Let's take a look at this one. We're going to multiply the radicand. So by now we're seeing where we could always multiply the radicands, right? So if we multiply these, we're ending up with 1080, but we're dealing with the cubic root, which means I need to find the biggest cube that could go into 1080. right? So if we try 216, in other words, 216 times 5 will give us 1080. This is the cubic number. Why am I focusing on cubic? Because this is the cube root. So these are the clues that will kind of skew your thinking so that you look at the appropriate places. So it means that I can rewrite this as the cubic root of 216 multiplied by the cubic root of 5. Now, what is the cube? The cube root of 216, that is 6. And we're left with 6 cube root of 5. And that's our final response for that. All right, in this section, what we want to do quickly is to take a look at, we just taking a quick look at how we could represent equivalent expressions for these, right? So we want to make sure that whatever we have there is the same thing. All right, so let's look. Number one is saying 9 root 10, right? 9 root 10 is not the same thing, right? 9 root 10 is not the same thing. But if I multiply the 15 times the 6, I'll get 90. So that means this is okay. And I'm seeing 10 times 9 is 90. And since a half power is the same thing as the square root, then we could take this as an answer as well. All right. Now, let's look at 3 times that. So 9 times 15. So this won't work because if you think about where this is coming from, it is actually coming from a 9. How? Because if we have this here, that means there was a 9 there already for us to get this, right? That means this, if I multiply the 9 times the 15, I'm not going to get 90. So we know that that can't work, right? So this is not an answer. This is very incorrect. So this is incorrect, right? Oh, this looks like something that works because this 3 is coming from 9. And then, so we're looking at root 9, root 10. So this is where this is coming from. So if I take the square root of 9, I get 3. And then I won't be able to take the square root of 10. So yes, this is a response. This one can't work because this is cubic root and this is square root. So, so the 3 answers are as follows. 1, 2, 3. All right. Sometimes when we work our problems out, we have to rationalize. And when you rationalize is when you're trying to get rid of a radical in your denominator. For example, like the root of 5 as well as the root of 8. So those are our issue now, right? Mathematicians do not represent, or they don't like to represent their response with a radical in the denominator, which means that we're gonna multiply the numerator and the denominator by the root of 5. So at the top, we're gonna have this. We're gonna have 2 root 6 times root 5 all over 5. All right? Root 6 times root 5 all over 5. Now, so with this said, how do we get the 5? If you multiply the root of 5 times the root of 5, it does give back 5, right? We did that with the root of 13 times the root of 13. In first case, we got 13. So this is 5. So technically, this is an okay response, as well as if I should break this further, it could be 2 over the root of 30 over 5, right? So this is also okay. There is no perfect square linking this 30 here, all right? Because 9 is not a factor, 4 is not a factor, 16 is not a factor, 25 is not a factor. So we're going to leave it as 2 root 30 over 5, or we could have left it at this stage. All right. So let's take a look at this other one. Now, in this case, all I'm going to do is I'm going to rationalize just the root of 8 because that's the problem. So I'm not going to trouble the 3. So at the top, I'm going to merge the idea, right? So if I multiply 8 times 28, I'm going to get 224 over 3 times 8. Remember that the root of 8 times the root of 8 gives 8. Hence, when this multiply by this, I'm going to have an 8 there coming out. So here, this is what we have at this moment, right? So I have the square root of 224 over 24. What we want to do, though, is to see if there is any square number, and then the number is limited. We want to see if any square number could divide into 224. So if this is 224, we're checking these numbers to see if they are factors quickly, right? So 224 divided by 4 will give us 56, right? So 4 and 56 can work. But you also want to make sure that the numbers are good, right? So if you try 16, 16 work with 14, right? That means this is a better number to use, right? 224. 224. If you divide that by 36, it won't work, right? And it goes on. So we do realize that for 224, we're going to use 16 to go with that. 16 and 14, right? So those are the biggest factors that we have that could work for that number. So let's go back. So we're going to split this into the square root of 16 times the square root of 14 all over 24. The square root of 16 will give me 4. So we have 4 root 14 over 24. Definitely 4 could cancel it itself. 1, 4 into the 24, 6. So my final response, I would have left it at 14 over root 14 over 6. That's my final response.